Good evening, everyone. We are here to present our system engineering project portfolio management system. Let's start with the overview of the project. As we all know that the investors in the Indian stock market has doubled since the pandemic period, but many of them have suffered from a huge losses due to the lack of proper knowledge and experience in this field. So we have make a stock prediction model which can be used by the new intraday traders for predicting the next day price of all the stocks listed in the National Stock Exchange and can also grow their profits exponentially. Let's talk about the requirements and constraints. So basically there are major two types of requirements. The first one is the functional and the second one is the non-functional. In the functional one, our system should be able to predict, appropriate and approximate share price of that particular share and also has to compare with the current share price and status with the help of the charts and the graphs. While in the case of the non-functional requirements, the system should collect accurate data from the source website consistently and also has to take care of the timing and environmental constraints, like the system can be affected by the unnatural crisis like pandemic or the changing of the government or falling of the GDP. Now, Abhishek will explain the tools and technology.
Here are the tools and technologies on which this project is built on. As the core language, we are using Python 3, in which we have programmed the prediction model and the user interface. The prediction model is based on the LSTM, and that will be explained later in this presentation. Another reason for using Python is Streamlit. We have exploited it thoroughly while building the UI of this project. And not to forget to mention here, Streamlit is a fantastic tool for creating beautiful UI using the very intuitive functionalities and the caching utility that it provides. We are using MySQL as our database, which has been provisioned from the Amazon Relational Database Service. The reason being is that while we are working on different parts of the project from different locations, we need a shared data source. And most intuitive solution was using a cloud-based database service. And next, for launching the web app, we have used the Amazon EC2 instance. In other words, we are using EC2 instance as a platform as a service. So that's all about the tools and technologies that we have used in this project. Now, the system architecture will be explained by Raja.
System architecture. So the first one is a user flow diagram, which is clearly depicting the complete path a user takes while using this product. So the first page is the sign in page. If the user is new to the website, then he can also sign in by creating a new account. Then comes the dashboard, where user can see his portfolio and the various stocks present in his portfolio and the current budget and the spending that he has done till now. Now comes the major prediction part. The user can predict in two ways. The first one is the sector wise, like the IT, pharma, and the second one is the company wise. After the prediction, user can also add these stocks in his portfolio, uh, and the quantity can also be managed in the same way. In the left hand side, the use case table is depicting the same thing. Like we have to collect the data, and we can also see the stocks in the two ways. The first one is the company wise and the sector wise. Then we have to consistently update the data uh, to predict the result appropriately and accurately, and at that we can also view the resulted outcome. Components and their relationships. The system has four major components, namely user, portfolio, companies, and company date-wise. The below diagram is a pictorial representation of how data has been stored in MySQL database. So basically, user entity contains the details of the user like username, password, budget, and many other attributes, while company entity contains the detail of company, and company date-wise entity contains the stock prices and other related info date-wise. and the portfolio contains the stock that we have predicted with their particular quantity. Next is methodology. The purpose method for developing the system consists of mainly three major steps. The first is data is collected and sorted for relevancy from various sources. Secondly, analysis is carried out on the collected data by examining the current market direction, tracking the industry group and specific companies, after which the data is represented and scored accordingly. At last, LSTM is designed and suitable algorithm yielding best accuracy is chosen to predict the stock value. Testing has been divided into three subtasks: unit testing, integration testing, and the verification and validation. So in the unit testing is carried out for testing modules constructed from the system design. Testing has been performed on each phase of project design and coding. The testing of module interface is carried out to ensure the proper flow of information into and out of the program unit while testing. Next is integration testing. It has been basically performed in white box testing and the black box testing. In the white box testing, internal program logic is exercised during this test to ensure that the logic has been properly implemented. While in the case of the black box testing, software requirements are exercised using this test case design techniques. Both techniques help in finding maximum number of errors with minimum effort and time. Now next comes the verification and validation. Verification of the project was carried out to ensure that the project meet all the requirement and specification of a project. Now Jake will going to explain the interfaces and its features.
Let's start with the interfaces and features. The first interface here is the sign-in page. As you can see, all the UI widgets have been made with Streamlit using the functions like header, text input, etc. So once the user entered his username and password, the SQL connector connects to the MySQL database and check if such a user exists. If it exists, then the user will be shown an option to go to the dashboard. The option will be shown here. Apart from that, user will also be having an option of sign up that will be shown during the demonstration part. Now this page is the dashboard where the user can see and manage his portfolio with the help of the options provided. As you can see, there is an update budget option in which once the user has put up his budget, then it will be sent to the database. And how? Let's see. First, we are setting up the connection with the database using MySQL connector. Then there we have written an update query and then have executed that query. We have also done proper exception handling wherever required. Below it, we are showing the summary of the stocks that the user possesses, which is done using the simple select query and the table function of Streamlit. Then we have the option to delete from portfolio. For providing a drop-down list, we are using the select box function from Streamlit. Then on getting the stock to be deleted, a delete query is fired which delete that particular stock from portfolio of that user. Then there is an option to insert into portfolio, which will be displayed once the user has predicted for a company or for the sector. Here we are taking stock symbol and quantity as input, and then on checking if the price is under the budget, the user can add that stock to his portfolio. There we are using an insert query. That is when the user press insert, then an insert query is executed. But in case user already have that stock, then he will be notified using an error message. Now the prediction model and the LSTM part will be explained by Jalaj.
So why LSTM? Long short-term memory LSTM networks are a type of recurrent neural network capable of learning order dependence in sequence prediction problems. This is a behavior required in complex problem domains like speech recognition, stock market predictions, etc. Let's take an example of sequential data, which can be the stock market's data of a particular stock. A simple machine learning model or an artificial neural network may learn to predict the stock prices based on a number of features like the volume of stock, the opening value, etc. While the price of a stock depends on these features, it is also largely dependent on the stock values in the previous day. In the conventional feed-forward neural networks, there is no consideration for the stock prices of the previous day. RNNs also cannot solve entirely due to the problem of vanishing gradient. So what is the vanishing gradient problem? We know that weight, which is applied on a particular layer, is a multiple of the error term from the previous layer. When dealing with activation functions like the sigmoid function, the small values of its derivatives gets multiplied multiple times as we move towards the starting layers. As a result of this, the gradient almost vanishes, and it becomes difficult to train these layers. LSTMs, on the other hand, make small modifications to the information by multiplications and additions. A typical LSTM network is comprised of different memory blocks called cells. With LSTMs, the information flows through a mechanism known as cell states. Let's take the example of predicting stock prices for a particular stock. The stock price of today will depend upon first, the trend that stock has following in the previous days, maybe a downtrend or an uptrend. Second, the price of stocks on the previous day since many traders compare the price before buying it. And third, the factors that can affect the price of a stock for today, like a new company policy or maybe drop in company's profit, etc. These dependencies can generalize to any problem as the previous sell state, the previous hidden state, and the input at the current time step. This way, LSTMs can selectively remember or forget things. Thus, LSTMs do not manipulate the entire information but rather modify them slightly, hence, they are able to forget and remember things selectively. So, we had enough of theoretical concepts and functioning of LSTMs. Now, we would be trying to build a model that can predict company-wise stock prices. We will use the library Keras, which is the high-level API for neural networks and works on top of TensorFlow. First, we will import all the dependencies. Now comes the dataset preparation part. Data is extracted from the relevant SQL databases through MySQL connector. Again, for better data visualizations, we have plotted the price history data of stocks of a particular sector using the matplotlib library. Then we will split our data in two parts, that is test and train, where the 220 days will be taken for training and rest 30 will be used as testing dataset. Now we know that a LSTM network expects the input to be in the form samples, time steps, features, where samples is the number of data points, time steps is the number of time dependent steps in a single data point, features are number of variables we have for the corresponding true values in Y. We then scale the values between 0 to 1 and 1 hot encode our true values. As we know, a sequential model uses linear stack of layers. Coming to layers, the first layer is LSTM with 50 memory units and its return sequences. This is done to ensure that the next LSTM layer receives sequences and not just a randomly scattered data. Finally, the neurons in the last layer are equal to the number of unique characters because we need to output one hot encoded result. So we have used Atom for optimizers and mean squared error as loss. The model is fit over 100 epochs with a batch size of 50. Eventually, after enough training epochs, it will give better and better results over the time. This is how you would use the LSTM to solve a sequence prediction task. For sector-wise, we have filtered each company according to their sectors and then followed the same steps as discussed earlier. Company stock insights. In this part, we have scraped the details of stock and important trading metrics to facilitate our user. We have used the getStats method from the Yahoo Finance library and finally displayed it with the help of Streamlit. So, these were the technical insights of the project. Now it's time for SWOT analysis of project. SWOT stands for strength, weakness, opportunity, threats. Now, talking about strength, the project solves a dilemma for the users about which stock to choose by analyzing their past performance. Coming to weakness, since we have incorporated only limited number of parameters, there is only certain degree of accuracy. Also, many of the indeterministic factors affecting markets are ignored. Third is opportunity. Improvements can be made to our data collection and analysis method with more accurate algorithms. And lastly, for threats, investors may lose money if they solely rely on this tool, especially in extraordinary conditions like pandemic. Finally, we will move to the demonstration part which will be presented by Abhishek.
Here is a brief demonstration of our project. The first page that user will encounter after opening this web app is the sign-in page. You can see on the left there are two options, one for the sign-in, another for the registration. If the user already registered, then he can simply log in from here. Then we check if such a user exists from the database. If a match found, then the login is successful and the user will land up to the dashboard page. The dashboard is a summary of the portfolio that user currently possesses. Let's see all the functionality it provides over the portfolio. Firstly, the user can say the total budget that he might have set last time. Then below it, he can see the current spendings, which is how much he already has spent on buying the stocks. Next, there is an update feature through which a user can change his budget by simply putting up a new price and then pressing up the update. As you can see, so the budget is updated. But to see the newly updated budget, we need to refresh the page. You can see here the current budget is that we have set right now. Next, we can see a table that summarizes what the user has in his portfolio, of what quantity, and the current profit he is making out of it. Now below it, he can compare his profit with what an average trader makes within the same band of spending. Please note that for showing the GIF, we are using the markdown correspondence provided by the Streamlit. Now, next we have the option to delete any stock from the portfolio, like this. So as you can see, the stock is deleted from the portfolio. So as we have seen, the dashboard has been designed to provide a very intuitive management facility to the user. Now coming to the predictions part, if you see in the sidebar, we have a company wise option prediction, a stock wise option prediction, and an option to log out. In the company wise prediction, the user can find the predicted price of a particular company like this, as you can see, the tomorrow's predicted price is this. User can also check how accurate our prediction would be with the help of this graph plotted here, and this is followed up by a page that enables user to insert a stock in his portfolio. This same page also explains the various aspects of the company, as you can see here, and all the details. Now let us ponder upon the sector-wise prediction. Here we can predict the price of the stocks of all the companies belonging to a particular sector. Let it be IT, financial or healthcare services or any other. Let's try and predict for IT sector. You will see here are the results. It also shows a graph which depicts the comparison of the performance of all the companies of that sector so that user can get a high level idea of how these companies are performing relative to each other. Then on the next page, the user can select the company of a sector that he want to insert in his portfolio and select what quantity that of that stock he wants to buy at that current price. So let's see a demo of inserting a company, let's say TCS or some other. So let's insert Wipro. So you can see it has been successfully added in the portfolio. The user can also see lots of stats about the company that we have selected above. As you can see, all the stats are here. Then at last, if all the of all our tasks have been done, then we can simply log out from here. So that is it, the brief demonstration of how this portfolio manager works. Thank you, sir.